Okay, in this video, we will show how to create an unstructured mesh and how to create a hybrid mesh. An unstructured mesh is especially useful for complex geometry, because for such complicated geometries, we probably have difficulty to create the corresponding blocks and then associate the blocks to the geometry, right? So in such cases, we can simply use the unstructured mesh. For example, for this geometry. Okay, if I want to create the unstructured mesh, then what I do is the first step is to create a so-called material point. This can be done by clicking Create Body button here under the Geometry tab. Okay, then I can create a body by defining a material point. And the method I'm going to use to define this material point is using the center of two selected points. Okay, I will select this point and this point. Okay, then you can see this material point called body is defined, which is essentially just the middle point of the line which connects the 2 points I just selected. Okay, here you should make sure that this material point defined is totally inside the geometry you want to mesh. Okay, so it should be located within our geometry. Why? Because the philosophy of ICEM to create the ICEM uses to create the unstructured mesh is it will create such unstructured mesh from this material point, okay, and gradually expand until the mesh fills the whole space enclosed by surfaces. Okay, that is, the mesh will gradually grow from this material point outwardly until the mesh touches a surface. Okay. So that's why this point has to be inside your geometry. Okay, after you define this material point, then go ahead to set up the global mesh size. Okay, here you can see I use 16 as the maximum element size. If you want to see how large it is, you can check this display. Okay, it's just this large. It seems pretty large, right? But in fact, it's not that large. So let me simply use 16 as the maximum element size. Click Apply. Then go ahead, click this Compute Mesh. Okay, this button is used to create unstructured mesh. Okay, just accept all those default settings, then click Compute. Okay, the computation begins. So basically, this is how you create an unstructured mesh. You can see it's really a simple procedure. Okay, I can see it's pretty slow to create the mesh, so I believe it is because I have also set up the mesh size at different parts of this geometry here. instead of just setting up the global mesh size here, because it seems that I will have lots of mesh. Yeah, I have a very dense mesh here. Okay, it's still working on the mesh. Okay, now the mesh is finished. So you can really see the mesh here. Oops. Okay, here is the mesh. It's very fine mesh. By no means can the mesh be such fine if I use 16 as the maximum element size. So I must also have already set up, say, the size here. You can see, in fact, I somehow, for some reason, I set up the maximum size also in this part mesh setup. Okay, and set the maximum size to be 1. So that is why here I have so fine mesh, because the setup here will totally override the setup in the global mesh setup. Anyways, this is how we create an unstructured mesh. You can see the procedure is really simple, right? You first create a material point inside of the geometry, then you set up the mesh size, then you just click this compute mesh button, then the unstructured mesh will be created for you. So you probably wonder why then we want to use structured mesh. Okay, because creating an unstructured mesh is so simple. The reason is because basically with the same number of mesh elements, that is the same number of control volumes, the quality of structured mesh typically is much better than the quality of unstructured mesh. When I say quality, that means the quality of the final CFD results. Okay, and so that means to eventually have the same CFD result quality, we will need much more unstructured mesh elements than using the structured mesh. Okay, so of course more mesh control volumes also implies longer CFD simulation time, right? It means you have to spend longer time and more computer resources to do your simulation. So that is why a structured mesh is also desirable in many cases. Okay, that being said, you can say basically the structured mesh and unstructured mesh, they have their own advantages and disadvantages, right? So sometimes we may want to combine these two types of mesh. That is, we may want to use a hybrid mesh. Okay, this can be done by merging the structured mesh and unstructured mesh. For example, here I have a pipe. Okay, so I have a simple pipe geometry, and suppose I want to mesh this geometry using a hybrid mesh, which means I want to use unstructured mesh to mesh the left half of the pipe, and using the structured mesh for the right half of the pipe. Then what I can do is first I will define this material point, right, inside the left half of the pipe. Okay, notice here I also defined a surface in the middle of the pipe to separate the pipe into two halves. Okay, so since I defined this material point here, so if I click this compute mesh button and ICEM begins to create unstructured mesh, the unstructured mesh will grow from this material point, okay, and gradually expands until the unstructured mesh touches a surface. Okay, so of course here we have this end surface, we have this middle plane surface, we have the side surface. So as you can imagine, eventually the unstructured mesh will fill the left half of the pipe, right? It's not going to fill the right half of the pipe, because the right half in fact is separated from the left half by this middle plane surface. Okay, let us first set up the global mesh size. Let me use 1 as the maximum size display. Seems okay. 1 is still very large. Right? Let's use 0.1. Okay. It seems that 0.1 is pretty small. Yeah, it's very small. Okay, let's just use 0.1. Then compute the unstructured mesh. Okay, so here is my unstructured mesh. Okay, as expected, it only fills the left half of the pipe, which is good. Okay, then we will create structured mesh for the right half of the pipe, and the procedure is the familiar procedure we used a lot, right? That is, we first create a block. Okay, you can see blocks are used for structured mesh, okay, and the material points are used for unstructured mesh. Okay, I will call this block, say, okay, that's fine to still call it live. Okay, that is the same part name as this material point. Okay, because this is a 3D geometry, so I will use 3D bounding box as my block type. And here probably I want to turn on the display of the surfaces, then select those surfaces here on the right half of the pipe, so that this block is only created on the right half of the pipe. Okay, then I will do the association. Say I associate these 4 edges to this circular curve, right? And these 4 edges will be associated to this end circle. Okay, then I will create the pre-mesh. Okay, so here is the pre-mesh. You may find that the pre-mesh quality in fact is not good. Right? Why? Because we didn't use O-grid for such a circular geometry, right? Okay, so now let's use the O-grid. Okay, here to use O-grid, again we have to first select surfaces. Okay, the surface, which we will eventually split the surface, right? After we create the O-grid, this surface will be splitted into 5 parts, correct? Okay, 5 parts, right? Part 1, 2, 3, 4, and 5, right? So this surface, this end surface, and that middle plane, in fact, are splitted by our old grid. Okay, then pre-mesh. Okay, the quality is still very low because there are only 2 points along those radial edges. So let's increase the number of points. Say let's use 12 points. Copy parameters, okay, so that such setup can be populated to the other similar edges. Okay, recalculate pre-mesh. Now the quality is high, right? Okay, that's good. Okay, notice that this structural mesh, in fact, is not a real mesh yet. It's a pre-mesh. Okay, that is the mesh for our reference. Now, since we are somehow satisfied, by this pre-mesh, I will convert the pre-mesh to an unstructured mesh. Notice I have already had the unstructured mesh for the left half of the pipe. Okay, so mesh already exists, right? So what I will do is I will merge this new created unstructured mesh from this structured pre-mesh with our originally created unstructured mesh. Okay, so merge. Okay, it seems that I have some error. Say unloaded unstructured domain. No such file or directory. Okay, it seems that I have to first save my project in some better places. Okay, then let me see. Let's recreate our unstructured mesh just to make sure that everything is correct. Okay, now I have this unstructured mesh, right? Then I redo this pre-mesh. Then I convert to unstructured mesh, then merge. Okay, now you can see they are merged. Okay, although here now we have this merged unstructured mesh. Okay, in fact, here this part is a structured mesh. Okay, but now they are all merged together and saved as an unstructured mesh format. There is one problem here, which is at this interface. Okay, this middle plane. These two sets of mesh, in fact, they do not match. Okay, you can see it's very messy at this interface. So if I close the other geometries and only display this interface, you can see both unstructured mesh and structured mesh. They coexist here, right? That's very messy. So here, what I want to do is I will match those points. Okay, I will somehow adjust those unstructured mesh points so that they can match my structured mesh points. This can be done by using Edit Mesh. Okay, here you can see Edit Mesh tab. Okay, then click here this button called Merge Nodes. Okay, merge nodes. Okay, then you can see this icon here, which obviously shows you a kind of hybrid mesh, right? The structured mesh with unstructured mesh. Okay. Click it, then click this button here. Then select this interface part. Okay, interface, because this is where we want to merge those nodes. Then click Accept. Then click Apply. Okay, now you can see we only have very beautiful structural mesh points, right? The reason is because now those nodes or grid points of the unstructured mesh in fact are moved so that they match these structured mesh points. Okay, so the unstructured mesh are still here, but the grid points at the interface in fact have been moved. Okay, so now the grid is very beautiful, and then you can simply output this mesh into, for example, the fluent format. Okay, so this is how we create a hybrid mesh, and this method is very useful. Okay, for example, if we want to simulate the airflow around a car, for example. Okay, here you can see the car is here. Okay, here we have a car, right? Okay, on the road. Okay, this is a car body, and of course, the air is going to flow over it, right, from left to right, I mean, in the positive x direction. Okay, when I simulate such a flow, of course, I'm going to mesh the space outside this car, right? Okay, I will have to mesh this whole space outside this car. The problem is this car geometry is so complicated, so you probably don't want to use structural mesh. At least you don't want to use structural mesh close to this car surface, right? Because that will be very difficult to find a proper blocking strategy, okay, to match this car geometry. However, you also do not want to use unstructured mesh for this whole space, because away from this car surface, in fact, the geometry is very simple, right? It's a very regular rectangular shape. Anyways, it's very structured geometry. So here you may want to use the hybrid mesh. The typical method is you create a small box here that encloses our complex car geometry. Okay. For the reasons which will be clear shortly, you may want to put the 6 surfaces of this small box in a separate part. Okay, for example, here we use this part called inner box. Okay, inner box, which contains these 6 surfaces of this inner box. Okay. Then you can create structural mesh outside this inner box. Okay, you can create structural mesh very easily for the space in between this small inner box and this big outer box, right? And you also can very easily create unstructured mesh inside this inner box. Of course, in between this inner box and this car surface, right? Because that is the space you really want to mesh, right? So for this space, you can first create a material point, right? Somewhere in between this car surface and this inner box surface. Then you can have ICEM to create unstructured mesh, right, in between this car surface and this inner box. Then afterwards, you can merge these 2 parts of mesh, right? Also, of course, you have to move around those mesh points along these 6 surfaces of this inner box so that the unstructured mesh points on those surfaces can match the structured mesh grid points again on these 6 surfaces, just like what we just did, correct? Okay, so in this way we can have a very good mesh with high quality, also not so many mesh elements. Okay, so this method can be used for any complex geometries, correct? No matter it is a car or a boat or an airplane, you always can use the same trick, the same strategy, okay, to create a hybrid mesh. Okay, so this is how we create a hybrid mesh. Okay, thank you for watching this video.